Hello everyone, and welcome to the lecture on Quicksort. So in this lecture, we'll get an explanation of Quicksort, look at some visualizations of Quicksort, and in the next lecture what we're going to do is a full implementation in Python of the Quicksort algorithm. So, to formally describe the Quicksort, what the Quicksort uses is divide and conquer to gain the same advantages as the merge sort while not using additional storage. As a trade-off, however, it is possible that the list may not be divided in half. So when this happens, we're going to see that performance is actually diminished. So, a quicksort, what it's going to do is it first selects a value, which is called the pivot value. The role of the pivot value is to assist with splitting the list. The actual position where the pivot value belongs in the final sorted list, commonly called that split point, is going to be used to divide the list for subsequent calls to the quicksort. So let's go ahead and try to look at a diagram to explain this. So here we have this array which has 54, 26, 93, 17, etc. And 54 right here, this first element, is going to be our first pivot value. So the partition process is what's going to happen next. It will find the split point and at the same time move other items to the appropriate side of the list, either less than or greater than that pivot value. So 54 is our first pivot value. So what we're going to do is we have all the steps marked down throughout this large diagram here. So we're going to look at each of these and go through it step by step. So let's go ahead and jump to the top first. Okay, so here are the top 3 steps out of that array and sorting it using Quicksort. So we have 54, our pivot value, and then what we're going to have is a left mark and a right mark. And these are actually going to converge on the split point as they go closer in to the middle. So we have that pivot value, and we have the left mark at 26. So since 26 is less than 54, that left mark moves to the right. Then, since 93 is greater than 54, we stop. Then the right mark is going to say 20 is less than 54. Stop. And this is what's going to happen here. So we have that pivot value. We noticed that we were able to stop on all the way to the right since we had a number that was less than that pivot value. And all the way to the left, we have a number that's greater than that pivot value. So the next step is to actually exchange these two values here. So now the left mark's at 20 and the right mark has 93. Then we continue moving the left mark and the right mark. So notice the left mark kept moving. 17 was less than 54, so it moved one more. 77 is greater than 54, so the left mark stopped. And then this guy went to 55 on the right mark. 55 is greater, so then it moved to 44, which is less than 54. So now they're both stopped. The left mark has a number that's greater than the pivot value. The right mark has a number that's less than it. So we're going to do another. And so now what you'll notice is the right mark having moved over to 31, and the left mark having moved over to 77, the right mark is now less than the left mark. So we found our what we call that split point. So what we do now is exchange 54, that pivot value, and 31, that right mark. So note that we're going until the right mark and the left mark cross. So to continue this, let's go ahead and take a look at some visualizations to try to get a better understanding of this quicksort algorithm. Okay everyone, so now we're here at the implementation of Quicksort notebook under the sorting and searching folder. And if you scroll down a bit for resources for review, you'll have the Wikipedia page, the visual algo, and then another animation page. So if we go ahead and click on the Wikipedia link, it'll take us here to the Wikipedia for Quicksort. And you'll note that there's a bit of an animation here, as well as a lot more information about Quicksort. Another diagram here, similar to the one that we were going over. And you can see there it has a left mark and a right mark. Although some people just think of it as one single mark going along. And you can check out the different partition schemes here and implementation issues. So I encourage you, if you're interested in Quicksort and more about that algorithm, you can check out a lot more information on the Wikipedia page. As far as visualizing, you can either go to sortingalgorithms.com, sorting-algorithms.com, and check out the Quicksort. And you can go ahead and see various visualizations. Look at these two marks as they're going. It's similar to what we were doing before. We have that left mark and right mark meeting and then doing those splits along those partition points. Okay, so Again, last resource to check out is this visualalgo.net sorting. Go ahead and click Quick here, and then you can go ahead and visualize the sorting mechanism. Here they're showing left and right marks a bit by color. So if you notice here, we're checking against 7 as our pivot point. So we're going along, and in this case, there won't be anything that's less than 7. The lowest number here is 7. It was meshed, but not less than. So we go out through this entire list, and we actually take 7 as the smallest number, so that iteration is complete. So the pivot's now actually at a sorted position. So our new pivot number is going to be 43. We noted that we had a 23 that was less than 43, and so now we're doing those splits. That's almost the same as when the left and right mark were meeting each other. Okay, so I encourage you to go ahead and check out this on Visual Algo. I'll go ahead and pause this now. And you can see that there's always some pseudo code here, as well as an explanation of what's happening. So this website's super useful. Just make sure you're in exploration mode to be able to explore, and you can create and sort various things as far as the arrays that you're going to be sorting through. Okay, thanks everyone, and I'll see you at the next lecture where we're going to be implementing our own quicksort algorithm in Python. Thanks, and I'll see you at the next lecture.